In the silent depths of our solar system, a small enigmatic planet orbits the Sun at a blistering pace. Mercury, the closest planet, endures temperatures ranging from a freezing -180 degrees Celsius at night to an explosive 430 degrees Celsius by day. Yet in the shadows near its poles, ice remains hidden, a cosmic paradox that begs the question, could a violent past be the answer? Scientists have long puzzled over Mercury's unusual composition. Recent studies using advanced computer simulations reveal that collisions between similarly sized protoplanets might have sculpted Mercury as we know it. Imagine a primordial Mercury with just 0.13 Earth masses and only 30% iron, colliding at speeds nearly 3 times the escape velocity of the pair. Could such a cosmic impact strip away the rocky mantle, leaving behind an iron-rich core that now composes nearly 70% of the planet? These groundbreaking simulations, meticulously controlled by researchers at the National Observatory in Brazil, produced a remnant that mirrors Mercury's current mass and structure within a mere 5% margin of error. How could such precise conditions have occurred in the chaotic early solar system? As we piece together the clues from these celestial collisions, one must wonder, are similar impacts responsible for the formation of other rocky worlds? And what hidden stories lie within the scars of these ancient cosmic battles? This exploration into Mercury's turbulent origins not only deepens our understanding of planetary evolution, but also ignites our imagination about the dramatic forces that shape our universe.